Hello. In this screencast I'm going to give you a bit of an orientation for how to get started with the Week 3 lab. So over here in Code Warrior, one of the first things that you'll need to do is actually create a new project. So I'm just going to show how that is done. So what we want is this item here, which is called bareboard project. So we're not using any of these other operating systems, we're running our code directly on the board. So we create a new bareboard project. And I'm going to call it Lab 3. Now you need to make sure that the location here is your Git repository, which you should have previously cloned onto a USB drive. So make sure that that location there is indeed your Git repository. You can browse for a different location if it doesn't come up by default. Next, you need to specify what is the actual processor that we're going to be developing our code for. And ours is MK20DX128 underneath the 50 megahertz header here. So you actually see the same model name appearing under different families, different speeds. We have the 50 megahertz version. So make sure that you choose that one. The connection that we use for debugging is called OpenSDA. So you have to tick OpenSDA and untick all of the others. We're writing our code in the C programming language, and all of these other settings are fine. So we click Finish, and a new project is created for us. So we can see here in main.c, this is where we would write our C code. And so there's a little basic kind of template here to get started. So looking at the lab task itself, there's a few things here that you need to look up in the reference manual, and so I'm just going to point these out because the reference manual is quite a lengthy document just to sort of help you locate what it is that you should be looking for. So the first thing that we need to understand is that every pin in the microprocessor can actually be configured to do many different things, and so there's a reference here to chapter 10. So I'll just jump over to the reference manual and show you what I'm talking about. So here in chapter 10, under pinout, we have this table. And so the way that we read this table is that we have a particular pin, and there's different numbers for the different packages under which this microprocessor is available. So pin numbers here, they all have a name, and then they have different functions for which they can be configured. So let me find an example here. So pin number 22 in the LQFP package is given the name PTA0. Now the default configuration for PTA0 is actually this setting here, which is JTAG, which is a testing protocol. But you can see there are various other alternatives that can be selected for that particular pin. So for example, under the mode Alt0 it can be configured with this function. Under the mode of Alt1 it can be configured simply for general purpose I/O, and we can recognize that this is the general purpose I/O mode because it has the name PTA0. So names of this form with PT standing for port, and then the number and the letter and the number, that means that that pin in this mode would be configured for general purpose input and output. So in this case what we would want is alt number 1 for this particular pin. So that's what this first table here in signal multiplexing is about. So moving down, once we know which of the alt numbers we want to configure, now we have to specify or have to find which register it is that we write to in order to actually set up those numbers. So we previously determined that we might want alt number 1 for that particular pin. Now how do we actually set that up? So over here in chapter 11 of the reference manual, there is a register definition for all of the registers that are that are defined in this chapter, that are part of this module. And so we see here we have these pin control registers for each of the pins. So for example, port A0 would be controlled by this particular register, which is at this address in memory. And then pin A1 is this address, and so on and so on. And you can see that there's many here. So each of the ports has up to 32 pins inside of it, and each of them has its own configuration register. And again, you can see over here the memory address at which you would find that register. All of these actually are configured in much the same way. We have the definition, which is down here in this section, for port X PCRN. So X and N obviously standing for one of those letters or numbers that we were just looking at before. And so what you see here in this table are all of the bits that make up this register. So this is a 32-bit register. You can see counting from 0 up to 31. And then each of these bits has a particular name that's given here. And so in the table beneath, it defines what each of those mean. So for example, the bit number 1 has this meaning. So if it is 0, then there's a pull up or a pull down resistor which is not enabled. If in turn you set this particular bit to 1, then there is an internal resistor pull up or pull down which is enabled. How would we specify whether it's a pull up or a pull down? Well, down here in bit number 0, we can specify a 0 or a 1 for a corresponding pull up or pull down feature on that particular pin. And so you can read through this table and have a look at all of the options which can be configured. But the one that's most important for us today is this setting here, this pin mux control. And so you can see this is in bits 10 through to 8, looking back up at that table. Bits 10 through to 8 here can take on one of these particular values. And so if you set it to 0, then the pin will be disabled. If you set it to value 001, then you get alternative 1, and so on for the other options here. So that's where you find information to fill in this table. Moving further down, once we have configured a pin for general purpose I/O, then we need to specify whether we want it as an input or as an output. So in input mode, we have the microprocessor that is reading from that pin, so sensing whether or not the voltage is low or high. Conversely, in output mode, we have the microprocessor acting as a voltage source and generating either of a low voltage or a high voltage. So now there's a reference here over in chapter 47. So let me scroll down and show you chapter 47 in the reference manual. So looking here at the memory map and the register definition, we see that there are various registers for various functionality on each of the pins, each of the ports. So the first thing that we're looking at is the data direction. That's what the prac sheet was asking us about, is the data direction register. So let's have a look at this here. So each of the ports that we have, so there's port A, port B, and so on, down here has its own data direction register. And remember that each port has up to 32 pins. So here we have a 32-bit register. We have 1 bit per pin inside of that port. So for example, if we're looking at the thing for register for port A, then this would be PTA0, PTA1, PTA2, and so on. Moving up here is as how each of these things are configured. And then we look down here in this table, and we see that if we put a 0 there, then that particular pin is configured as input. If we put a 1, then that pin is configured as an output. So this is where you look to find information to fill in this table. And finally, once we have set up the pins as an output, then we need to control the actual data that we're outputting. And so again, looking into the reference manual, you will see there are various registers that can be used for this purpose. So for example here, the port data output register. This register configures the logic levels that are driven on each of the output pins. And so once again, we have 1 register for each of the ports, and then that register contains 1 bit for each of the pins. And so logic level 0, logic level 1 can be configured according to what you see here in this table. So there are also some other registers here which can be used. And so, for example, writing into the port set register can turn on particular bits. And then there's a clear register where writing can clear, so that means putting to 0 certain bits. And there's a toggle register for toggling particular bits. And again, you can read about these here. And so there's various options that you can use when you want to actually set the value. But that's where you find them in that reference manual. So I hope that that little orientation has helped you figure out what it is that you need to do to actually get started in the lab.